All right, folks. Here's some guided notes on 2.2 evaluating limits the hard way. So the first time we did this, it was pretty easy because all you had to do was plug stuff in. And I want to remind you, before you do any of these problems, you first try a limit problem with direct substitution. That's what we did last time, where you just try plugging the number in. I said you don't want to waste your time with fancy moves if they aren't necessary, because you could have a problem that, looks like you need to start factoring your stuff, but you don't even notice you could have just plugged your number in and been done really quickly. All right, so the next question is, if direct substitution doesn't work, what should I do? I guess, and then there's a previous question is, what does it mean for direct substitution to not work? Well, when you plug in x, or when you plug in the number for x and the answer is 0 over 0 or infinity over infinity. If you get either of those cases, it's called an undetermined case or an indeterminate case. It doesn't mean the answer is 0 or infinity, or it could be any answer. It means you don't know the answer and you need to do more work. I did say careful because if you get just a 0 on top, there is an answer. Like, your answer would be 0 for a limit. If there was like just an infinity on top, then your answer would be infinity, right? So if there's just one 0, if there's a 0 on bottom, let's say it was 3 over 0, your answer is the limit does not exist because it's an asymptote. So yeah, basically the two cases you're worried about are 0 over 0, infinity over infinity. That's what it means when direct substitution doesn't work. All right, so here's an example. If I take a -6 and I plug it in here and here and here, let's see what happens, because that's what I should try first. -6 squared is 36, right? 2 times -6 is -12. Then I have minus 24 up top. And on the bottom I have -6 plus 6. So I get 0 over 0. That's one of those cases where I don't have an answer yet. It's indeterminate. So I got to do some more work. Make sure you don't lose this limit thing. I know it's irritating to keep writing, but the first and easiest form of algebra trickery is to see if you can get something to cancel. Okay, so our game plan with problems that look sort of like this is to factor, get something to cancel, and then plug in for x. So clearly plugging in for x at the beginning didn't work. I need to do something more, and that is factor it, see if something cancels, and then hopefully plug in for x will work. So the top factors, and like I said at the bottom of this page, if you're not good at factoring, go to Khan Academy and look up factoring trinomials. Watch a couple of videos. So what multiplies to make -24 and adds to be +2? We have a 6 and a 4. And the negative goes on the 4. Okay, which is good because now the x plus 6 is canceled. And you're left with the limit as x approaches -6 of x minus 4. Now that, I should be able to plug a -6 in and get my answer. -6 minus 4, oops, is -10. There's my answer. Guarantee if you checked on a graph, the height of the graph, the y value of the graph, approaches -10 as x gets to -6. Clearly, you're not allowed to get there, but it's what it approaches. All right, same deal on the next one. We try this one out, and I just wanted to see if you remembered two things. Well, first plug it in. You got 2 to the 4th is 16, and ooh, we're at 0 over 0. But you should try, because you'll waste your time one of these times. I'm a sneaky snake, and I'll plug in something that you should have just tried. Don't just go to factor mode without trying it. All right, so two things. One, I want you to remember to always look for greatest common factors, like a 6, just pulling that out. And two, noticing the difference of two squares. And then this guy factors further. That guy does. This one doesn't because it's a plus sign. But the other one keeps going. So x squared minus 4 is x plus 2 and x minus 2. This is just good factoring. Let's see, those cancel. And as soon as those cancel, I don't have to do any more, algebra work. I am ready to plug in. And, don't waste your time trying to FOIL stuff out or anything like that. I just cancel those two off. As soon as I get things to cancel, my problem will be more accepting of this number to throw in. Because it was 0 over 0 before. Let's see if it still is. So I plug a 2 in there, and I get 4 times 2 squared is 4. So 4 plus 4 is 8. The bottom is 6. So 4 times 8 is 32 over 6. Whatever 32 over 6 is. So it's 5.3 repeating. All right, so that's that one. And once again, that is the height, the y value the graph approaches as x gets closer to 2. Doesn't ever have to get there. All right, and then we bring up a tough factoring one. We'll try plugging this in. Be careful on this because some people mistype it with negatives. Kind of order of operations thing. So if I plug a -1 in here and it gets squared, it turns into +1. So that's a 2 minus -1, which is really +1, minus 3. And on the bottom you have -1 plus 1. So I got 0 over 0. And then, so the top factors. This is just the tougher factoring. Limit. Don't forget your limit thing. You can't just let it disappear and come back later. You need to keep it the whole time. So this is the tougher factoring because there's a 2 in front. So the question is, what multiplies to make not -3, what multiplies to make -6, 2 times -3, and adds to be -1. Now there's many ways to do this. You could do guess and check, that sort of thing. A -3 and 2 works. Okay. So I know my middle terms are going to be -3x and 2x. And first times first must make this. There's only one way to make that, 2x squared by 2x and x. So the way I do it is I do, okay, if 2x times something has to make one of those two numbers, I put a +1. If x times something else has to make the other number, I put a -3. It's just factoring from Algebra 2 and Pre-Calc. Good news is you do have a pretty good guess because you want something to cancel with that bottom. So if I was a betting man and I went to factor this top, I bet one of the factors is x plus 1. Then you can probably guess and check your way a little better. So here we go. It just boils down to this. And now, as soon as I get something to cancel, it's okay to plug that in. And you get -2 times 1 is -2, minus 3 is -5. So all these problems didn't work with direct substitution, and they did work with once I canceled something off with factoring. Okay. let's get the distribution type in here, and then I'll have to make a second video for the two tougher ones. Okay. Okay, distribution type game plan is just distribute or FOIL until you can't anymore. Distribute till you drop. Oh, that sounds good. And hopefully something will cancel. Now you're going to see this in the future. This is a little preview. This is called the limit definition of a derivative. But the same rules apply. I do want to plug this in. By the way, if you're freaking out about this, delta x, think of it just like you would if it was a y. The delta just means change in x. So if this were a y, it would say x plus y squared minus x squared over y. Delta means change. We'll get into that later. But basically, I'm trying to put a 0 in there and there. So if I put a 0 in there, it becomes x squared minus x squared on top. If I put a 0 in here, it becomes 0 on bottom. And 0 on bottom would be undefined, but 0 over 0 is indeterminate, so you can't do it. Now there's no factoring or anything. What I hope happens is, if I distribute everything, maybe I'll get lucky and something will cancel. Distribute till you drop and cancel at the end. Okay, so let's try this. Instead of the top being x plus delta x, since it's notes, we'll do this. You have to keep track of your work pretty well. So you're going to FOIL this out. So we'll take it a little slow this first time. X times x is x squared. The outer is x times delta x, which really doesn't do much. Just write x delta x. If it helps you to put these in parentheses to remember that's just a single term, then do it. Inner is x times delta x. I know it says delta x times x, but it means the same thing. And last times last is delta x squared. Okay, now don't forget this guy. A lot of people miss that. It's hanging on at the back. Okay, so I'm doing nothing more than foiling. Now, what you should notice is these two are similar in that they both have a delta x on them. So there's two of them. Instead of x delta x plus x delta x, there's two of them. The other thing you should notice is this guy is positive and this guy is negative, so they go away already. So all that's left is on top you have two of these and you have one of these delta x squared. And what's nice is, see how everything has a delta x in it? You could take out a GCF of delta x and cancel it off. So we're almost done. It's moving in the right direction. Since everything left has a delta x in it, you're basically killing off one delta x from here, one delta x from here, and one from here. Let's see. I'll do this the first time. Usually you won't see me actually FOIL or just extract this out. 2x plus delta x. That's what would happen if I took out an x, if I factored out. The reason I did is now you can see where they cancel. And then finally, am I allowed to plug in the 0 for delta x? Yep. And what's left? 2x. It's a weird answer. All right, I'll come back with the other video on the two other harder things.